the presentation of Marko's work. Marko did his research work mainly on IoT. His activity was concerning different application of IoT technologies in the manufacturing environment. The idea we tested was a sort of PDCA, a continuous development and improvement method to integrate the systems in a company from being totally not digitalized into a system that is more and more connected. So the idea is to move by using the mic approach. It is based on definition of the problem, measure, analysis, improvement, and control. And this loop can be repeated several times. He applied this approach to different cases, one in Tuscany, in particular by using Zero-defect technology, so hardware and software, to a company that is producing industrial brushes. The process Marko followed was oriented to gather the data, to make the data accessible, to take the data, and to make prediction on how the system will work in time. Let's see in detail. He applied this approach, this method to two cases, one in industrial setting, the one I said, and one about open architecture additive manufacturing in DTU. So what he did, the activity is very at low level in terms of coding, C++, Python, and so on. Mainly, he prefer working on routines in C++ to be fed upper. The case is the retrofitting of this machine. This machine is a particular broaching system that is able to capture to perform the broaching of the inner of a polypropylene tube by using this machine that was designed for the company. No other machines like that can be seen elsewhere. The machine was totally analogical, and the goal was with Oliver to develop the broach, to characterize the system, but with Marko to make the system being 4.0 compatibility. So the idea is that Marko retrofitted this machine and understood how the data are telling us something. In particular, he integrated the information by using the 4.0 box and some other conditioning system in a standard rack. From the field, we got the data, and the data are sent to the cloud in order to not only store, not only visualize, but also make analysis out of them. Here you can see the data from the part concerning the piston that pass through the tube, and then since it is an oil pump that activate the piston moves the broach back, and here is the broach passing through the pipe. The result is this analysis that changes every time that the tube is a pipe is broached, and it is because of the material, the internal diameter, how the different blocking system are located, and so on. So it is quite complex to make prediction out of it. But by analyzing different curves, it is possible to discriminate between different tube diameters that are using different broaches. So classifying the different tubes without asking the operator to tag is important as well. The system is able also to detect how the system, the tube is clamped. For example, this one is with standard clamps. You can see the number of clamps that are blocking the tubes here in the figure. We have 1, 2, 3, 4. And here you can see that we modified by using additional bigger pipes the way these clamps, this V bracket, are blocking the tube. The result actually is a better result. And we were able to do that from remote. So the company is in Florence, and from Pisa, we were able to discuss with the operator and asking them what is happening, because we see the data that are telling us that something is wrong. And then we were able to monitor all the day long the different tubes they were broaching, understanding if something was going bad, and interacting with them in order to tag the data. The same approach has been used for the open architecture concerning polymer laser bed fusion, powder bed fusion in DTU, thanks to the collaboration with the PhD student and the research group. Same approach used in order to understand how the system is working, and if it is possible to control the heating system in order to create this automatic online control system. More or less other activities done during this period in DTU. And now the part concerning prediction. So what Marko is doing is try to understand how it is possible to decompose this curve into smaller parts, understand when the broach is entering, so filtering the data according to the inner diameter of the tube, getting information about the material. So if the material is easy to be cut or not, by simply analyzing the shape of the curve, and then predict if something is happening at tip level. So is any tooth damage? Here we can see the small presence of the different level of teeth that are entering into the pipe. And then by using a synthetic representation, is try to get prediction in order to make maintenance on the broach. That's it what Marko almost did, and the activity is still doing in order to make the system able to evolve by understanding the data, reducing the time operators spend in tagging, and make the system available also for a small enterprise as the one in Firenze. Thank you very much, and see you soon.